Power Hour. Welcome.
Hey, and happy Saturday to you for Power Hour number 266. We've done 266 shows. Can you believe that? Some of you have been around since the day one. Let me get this thing off. Get a different share going here. Give me 1 second to get things rolling. Rid of that, rid of that. Go here. Here we go. Yeah, I should be able to see that now. Yeah, so 266 of them. People ask where they are. And if they can record themselves. The answer to that is no, but it's on our membership site. We keep everything there. It's pretty cheap. We'll put a link in the chat for it. So, and then you can see them all. Think about that. That's 266 hours. Yeah, we've had everybody on. We've had not everybody. We've had a lot of people. We've had AOPA legal team. We've had Gary Reeves, had Rod Machado, we had Greg Brown. We had teams of people that panels, every imaginable topic you can imagine. So anyway, I'm glad you're here. It's a really good way to spend your Saturday, especially if uh, if it's raining or snowing or from wherever you are. The Some people complain. They say that it's a bad time, but really we can't find any other time that works. I don't want to do these like at 9 o'clock at night. I'm not in the mood. So that's the only way I can address like the West Coast time. So I think getting times to fit is very challenging. So I just have to say, well, if you want to show up, you can. That's kind of how it is. I haven't found a really good time slot other than this one. I don't really have any other things. Like I tried, but I can't find any. So that's why we do them that way. So hello from all you people coming in. There should be a lot of you today. There was many, 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 many opt-ins. We have 486 in the room and just getting started. And maybe it's a topic that people like. It's a topic that's one of these challenges in aviation. So it's aircraft systems, right? So a lot of times, it's curious because people really want to know uh, how these things work, but yet there's some amount of effort that goes into really understanding them, and the effort can be a little bit of background in science, a little bit, and not be much. uh, just a little bit of stuff. And so I intend to help you with that today because, in particular, with the electrical system. Because if I go to any flight school and I ask the flight instructors teaching systems to explain various things, they either get it wrong or they don't quite have the complete picture. And so the reason for it is they have no background in electricity whatsoever. It's just like somehow magically that information is going to get in your head. It just doesn't. Certain things you can get in your head just because you've been around long enough. Like I think you would know that if you put a bucket over your head and you pour it, it'll come down on your head because it's gravity, right? I think you would know that. That bucket challenge. Remember that stupid thing? That thing, right? Ice and all this, whatever that thing was. But anyway, you would know certain things because you've seen it, right? So you can understand how fuel might get from a Cessna's wing tanks down to an engine by gravity. I don't think anybody really has to talk too much about that to you. But when you come to the more abstract things that you can't see and that you've always been afraid of, like you've been afraid of math, most of you, not all of you, you're terrified of that, and you've been terrified of electricity, right? That's good reason. I got shocked once. Oh God, I worked in high voltage. Ooh, there's an area that I don't know. Anyway, I worked on a high voltage laser. I was a laser engineer, and I took the cover, defeated the interlocks off this relatively small uh, frequency double gag laser. And for whatever reason, I have no idea why I did it. There's a high voltage circuit board in there. And to me, at that moment, it was just a circuit board. And I touched it. Oh boy. So I was in one of those chairs with wheels on it. I went about 4 feet back, passed out, head hit the ground, right? And then I woke up and they took me to there's an urgent care right next door. So I went there and there was a bunch of ooh, it wasn't good. So yeah, I know why you're afraid of electricity. There you go. That's fun. Okay, so we'll get started here. So I just wanted to set the expectation of what we intend to cover things in a pretty good way. We'll cover most of the systems. I don't think we have time to cover all of them, but we will get to the electrical system, and I think you'll be able to understand it a lot better. I also put some links in here of some videos that I think are pretty good. Some resources. I'll go through those as well. We'll take a break in about 20 minutes, and I'll tell you some of the things we're doing, and then for 5 minutes, and then back into it we go, and then we'll round it out at the top of the hour finish. And then the room will remain open after that, after we close out the show. And it'll be the wings credit will be near the end of the show. So if you're waiting for that, it's going to be in the chat. Okay. The only way you can get it or anything is just going to be in the chat. Okay. So don't try to put your email in there or your name because I'm not going to look at it. Okay. We don't do things manually like that. It just takes too long. So in the chat when that time comes, but I'll let you know when I start seeing it. The other thing is then after the set, then we'll open the second hour. Now you don't have to stick around for any of that. You can leave if you want, but we open the mics and I go through all the chats that are relevant. And then after that, we open up for conversation. And it can be about this topic, it could be about other topics, things going on in industry. It could be anything. It's just a chance to make use of the Saturday. Okay, let's get rolling here with this. So I'm basing this on a 172N model systems. Now your airplane is going to be different unless it's a 172N model. But I think I use this because it's very relatively simple systems, and then we can talk about we can talk about other airplanes if we want. But if you have this as your basis, then I think you could probably talk about anybody's electrical system to begin with and other sorts of systems to begin with. So let's start with that. So the Cessna 172N model has a fuel system, and here's a diagram of it, and it's not a bad diagram. So there's its gravity fed system, and so it's interesting. I'll give you some insight into these things because there's a lot in here that's not really talked about in the manual. Not a lot, a few things. The first thing is that this tank is vented, the left tank. So if you go out to a Cessna 172 and you look at the strut, you'll see there's a tube. How do the magnetos? They're high voltage generators. I'll show you how those work in a second. So I just saw that in the chat. Okay, so let's get onto it here. So that tank is vented directly outside and it's behind the strut so air can't get into it and pressurize it. And if you look at the other tank, it's vented through a tube here. Now, you say, what does venting mean? Well, it means that you have to, when the fuel drains, you have to replace what's on top with air or it will pressurize. So imagine you take a plastic bottle of water and you start sucking on it, but you don't allow the air to get back in. Then the thing starts collapsing, right? And eventually you just won't be able to do it anymore when you can't match the pressure. So that's why the tanks have to be vented. Now, it's interesting because there are two filler caps here. And because this tank is vented directly and this one's vented through a tube that runs the other side, this tank drains better than the other tank, the left one. Now, Cessna made an attempt to fix that in the N models. And what they did was they vented this cap, but not this one. So the right one's vented to help make a better venting system over here to maybe equalize so they get better fuel, not a fuel imbalance, right? So if you look at the 172N models, you'll find there are chains on the fuel caps. And that's so you don't take this one and put it over there or that one and put it over there. That's the reason, because only one of them are vented. In the S models, they changed their strategy and they said, well, got a lot of fuel. We want to put a little more fuel in the airplane. And who cares if there's a fuel imbalance? That's what you got a fuel selector for. You can figure it out. Then we don't have to worry about that anymore. So that's what they did. So in the current 172S models, they don't have, or R models, they don't have vented caps, but they do here. And then you have a fuel selector that has the off switch built into it. So on the 172S models, it's a separate lever. And the fuel selector is left, right, both. In this case, off. And then from there, if we keep going down, there's no electric fuel pump in a 172, and it's a carbureted system. So it doesn't use a fuel injection system. So it has a manual primer pump here, which is on the panel, and then you pull out, let it fill up with fuel. I've seen people try to pump it. That's not. It's a tube. So just a pipe, a tube. So you pull it out, let it fill up with. You can hear it filling up with fuel. Squeeze it back in there. Okay. Good God. Alrighty, and then you have a carburetor. So there's a fuel strainer. There are 3 fuel drains on this airplane. There's one under each tank and one here at this strainer. And that's on the bottom of the airplane. So fairly simple fuel system. There are 43 gallons total and there's 40 usable. And the lowest fuel grade you can use is 100. And as we approach this new year coming, we're going to have a guest on, hopefully from EAA. But it could be from really anywhere. Or I could get someone from Reed Hilby Report in San Jose. They would know as well. Talk about unleaded fuel, because I have some questions. I have not been around unleaded fuel. but I know some of you have. So I would have questions about mixing compatibility. Do we need an STC? I'd have a lot of questions there. What color is it? I would ask a lot of questions. So I think we can have this conversation. I think we're going to need to know about that and teach that pretty soon. So that's what I would say. But the lowest fuel rate here is 100. It's green. We don't have it in this country. It used to be in Mexico quite often. We have 100 low lead, which is blue, dyed blue. Okay, so we all have questions, right? So I'm working on that. This is my diagram of the same fuel system. I made kind of engineering drawing. This is a symbol for a fuel selector, a strainer, and I put the quantities and everything on the image. So you have this. This presentation is yours. You have that as a PDF. Okay, so there's that. And the engine system, we have a horizontally opposed. That means the cylinders are opposite each other. Like turn this main drive, right? It's air cooled. We don't have any liquid cooling in this airplane, and it's made by Lycoming. It's a very old engine. It develops 160 horsepower at 2,700 RPM, and the ignition, to get into your question here, is via two magnetos. So we'll talk about that in a second. So these engines are quite old. They're from the 40s. They start off as ground power units in the Navy, and they're very thick metal. And again, they're only air cooled, so they're not liquid cooled. There's a lot we could do if we had a different engine technology, but because of certification of airplanes, we're kind of stuck with these. They have made attempts to use diesel engines. So the 172 has a variant called is it called a Red Hawk? Yeah, that has a diesel engine in it and FADEC control. They're not wildly popular. But good technology. I like diesel a lot better than this. The only thing I don't like is the fuel. When it gets on you, wear it all day. It's like you can't get it off you. So there's that. So I guess we can talk about this engine here for a second. And maybe it's good if I were to have a graphic. So I don't have a graphic of the four strokes of the engine, but you know what they are. But most people don't understand how the valves work on the top. So let me just go get an image here from the PHAC. Okay, let me share it. Then you can maybe understand a little better. Here we go. So this is, I'm not going to go to the website, but here it is. These are the four strokes. Intake is the first one, then compression, combustion, and exhaust. And there are two valves up here that open and close. One is the intake valve over here, and this is the exhaust valve. So the intake valve comes from the manifold where the fuel air mixture is. And this one goes out overboard through an exhaust manifold that you pre-flight that. You go like, ooh, still on there? Yeah, okay. So what happens is then you're trying to take something like this, a piston that moves up and down. And eventually you're going to translate that to turning something like this, a shaft of some kind. So the up and down of the piston is going to turn into rotating a shaft, which is what the propeller is going to be mounted on. And then on inside of the engine, there's something called a camshaft. And it is a solid piece of metal, and it has little lobes on it every once in a while. The little lobes. And those things come out. And at certain times, they push or to open this valve, or they push maybe to open that valve. So they get the timing right. Right? So you want to, because I'll show you as we go. So the first thing I want to do is open the intake valve. So here comes the camshaft. Tink goes across that valve, and then this valve, and then all the fuel air mixture starts getting sucked in because you're starting the engine. You got the thing turning over, and now you're pulling this piston down, and then that pulls in, sucks in the fuel to air mixture, and then once that's done, then the camshaft goes and closes both valves. So both are closed. And we push the piston up and we compress all that because we're going to get a more concentrated mixture that way, right? And right after this piston comes to the very top and just starts its way down just a little baby. Then we want to explode the mixture, right? So there are two spark plugs, and spark plugs are just electrodes. There's no brains to those things. They're just all they are two electrodes that are separated by a little bit. So you can get a spark to generate across there if you have high voltage available from somewhere. And so then we fire the mixture, and that hammers down the piston on its own. And then what happens is when it starts coming back up, the camshaft comes over and opens the exhaust valve to allow and that repeats. And so these things are timed in such a way that the things are rotating and they fire at different times to keep the shaft turning. Okay, so then you ask about the magnetos. So magnetos are not really electronic. They are high voltage generators. Okay, so let's talk about that just for a second. So if you take a coil of wire and you take magnets and you were to spin the magnets really quickly around a coil of wire, you will generate electricity through electromagnetism. The faster you spin it, the more electricity you get. And the bigger the magnets, the more electricity you get. The more coils, the more electricity you get. So this is part of the heart of the magneto. It's spinning and it's connected directly to the engine via gearing. So you don't need any external source of power or anything. All you need to do is spin those magnets inside on a shaft so that you generate electricity. And then you have another coil, a step-up transformer, which will take that low voltage and turn it into a higher voltage. Okay. And then the only other thing we need to do then is we don't want to fire that magneto all the time. So we want to say we don't need any electricity high voltage from you now until we get to this point. So there's timing involved, and there's a little device in there that you'll see mechanics. They take the propeller and they're moving around like this and doing something. They look at stuff that they're setting the timing so that the magneto fires at this time. And that goes into the two spark plugs. And because there's a gap, that'll generate a little spark across there and explode the mixture. So you just need the engine running for the magnetos to work. And they're directly connected to the engine in the accessory case via gears. So if you want to go get one and I say, put your finger where the spark plug, the wire are going to come out for the spark plug, and I spin it, you'll get shocked. Okay, so that's that. Okay, now let's go back to the presentation. I don't want to spend too much more time at that because I want to get to the end, right? Eventually. Okay, so that's what that is. Its air is entered into the mixture through the very front of the airplane. You see looks like a filter. And the exhaust manifold goes outside. Now the heater uses the heated exhaust, and they put a shroud, like a metal container around it. And that then gets ducted into the airplane. So there you go. All right, that's enough. Now it's interesting too. Another thing you might not know is why does the airplane have a spinner on it? What's the reason? Uh, and the reason for it is because it directs airflow. It's shaped this way so it directs airflow across these fins here. So it directs airflow into there for engine cooling. That's what it's for. So don't also, it's one piece. Don't push on it when you're pre-flighting or you're towing the airplane because that's one piece and it's got a nut plate. And it's very easy to crack the nut plate. And so don't leave that thing alone. Okay, stop pushing on the spinner. It is a wet sump oil system. It's very simple. So it means at the bottom of the engine, there's a pan, oil pan, and there's a pump down there. And so when the oil gets all used up here, it starts by gravity coming down, it collects in the pan, and the pump pumps it and throws it back up there. And so all the oil is contained within the engine. In a dry sump system, the oil is separate. So I had an aerobatic airplane that had a dry sump system and it had a valve. So when you went upside down, it could change the direction of oil flow. But here, this is what you've got. So all it is it's a wet sump oil system. Okay. And these are the grades. This is in there for you. Most people are using a multi-grade oil like this one now that changes viscosity as it needs to. So anyway, you will figure out. But in your airplane's manual, it will tell you under service and handling the grade of oil to use. Okay, so there's that. For the cabin heating and ventilation system, this is kind of how it works on the Cessna. So this is the outside air that's through your air filter, right? And it comes in this way. Let me grab my glasses here just for a second. So this is for the heating system. So it comes around the shroud right here. And then that gets ducted into the cabin by a valve that you can move, right? A lever that you can move. The fresh air for the airplane comes in from a little flap that's outside right here. It opens up on the side when you move the lever, and that just gets ducted straight to the bottom of the airplane where your legs are. And then you have other holes up here in the wing that ducts air in through here. Now, these aren't for the 172, except for an R model. Okay, so there's tubes for the 172N models. You just have one tube on your side and one on my side. The farther out you pull it, the more air you get. You can direct airflow. But in the S models, you have regulators. I call them eyeball vents because they look like an eyeball, right? You can move them around like an eyeball. There you go. That's what that is. And then the back seat has one each for each side. So that's pretty simple. Now we have the electrical system. Finally, right? We're going to spend quite a bit of time here because I think this is the Achilles heel of aviation. I think it's really funny how pilots behave. They're career pilots. So um, at one time, SkyWest was the premium regional carrier to work for. Maybe it still is. I don't know. And when the hiring was slim, uh, and they had plenty of CFIs to pick from. Uh, their technical interview was quite hard, and they also had a sim interview. So they did a HR interview, they did all the background stuff, and then they brought you out to Salt Lake City, and they did sim, and they did a technical interview. And of course, all these people want to know what they're going to ask, right? They all want to know what they're going to ask, right? What's on the test? So it's not a test anymore, right? So what they were asking that freaked them out. So it began freaking them out because they said, "Oh my God, I really need your help. What do you need my help with?" Well, they want us to take the last airplane we flew, whatever that is, and explain the electrical system, including the starting circuit. How do you trace all these lines and all this stuff? I went like, well, you're not going to be able to because you don't know anything about electricity. Once you know something about electricity, you'll be able to do that. That's my simple answer. So I can't just show you. I could show you and keep repeating it over and over again until you got it, but you still wouldn't understand it, right? So we need to kind of understand is what that means. So this is just pictures, but it gives us an idea of something. So we have a battery over here. And then there's something. What the hell is that, right? What the hell is that? Master solenoid. Now, it depends on what airplane you're in, which manufacturer, and even to some degree what year, what model this airplane is what they'll call this thing. Sometimes they will call it a solenoid. Sometimes they'll call it a relay. That's what they call it. A 172N model is a relay. And then they'll call it a contactor. All those three things in aviation mean exactly the same thing. It's that thing. So we're going to talk about what that is. And then we need a common connection point. We need something where we can connect everything to. The battery can be connected somehow to it, the landing lights, the flat motor, everything. So you need a distribution bus like this. It's just a piece of metal. Could be simple, right? So let's talk about it. Because that's another thing that freaks people out too is what is a bus? What is a bus? That's not something you drive to go to school, right? Or you sit in to go to school. Although I do like that YouTube video with the dogs going to the dog park in the bus. That's pretty good. If I were a dog, I'd be in hog heaven with that. It's a bunch of dogs. They go pick them all up and they open the door. They all have their seats and you got to go to the dog park. And when they come back, they're sleeping, right? So that's pretty good right there. So, okay. So a bus is a distribution system. So let's just envision it. Let's just say we have something like a phone or a piece of metal, something difficult, but okay. You could imagine it, just a piece of metal. And then we're going to bore a hole in it. So we bore a hole in it, and then we're going to thread the hole. Okay, so far so good. Then we have the lead from the battery. It's a relatively big thing, right? Like this battery lead. And then we put an eye hook, which is crimp an eye hook on there. So an eye hook is like a flat piece of metal that has a hole in it. And we connect that there. So the idea is we're going to take a screw and we're going to put that eye hook flat on there and we're going to screw it down so we get a really good electrical connection. And then we're going to do the same. We're going to bore holes in this thing for the flat motor, for the navigation lights, for this, for that. We're going to bore holes. And we're going to thread those two, and we're going to take the radio wire. We're going to take and we're going to just screw them into that flat surface. And that gives us a really good mechanical connection because otherwise I don't know how else we would do it, but that's how a bus looks like, that idea. Okay, so that's what it's just a distribution way. And then we have ways to turn things on or off. And then we finally have an alternator over here, which generates electricity when it's spinning in a similar way to the magnetos. I wouldn't say it's exact, but the idea is the same. And then we have a voltage regulator, which then checks the output of this and says more or less, please. More current, less current, more spin. You can't spin faster, so I got to do something to make this better. So it's just checking everything, and it's providing consistent output. And then it feeds back to the bus, and you can see that through it and through this way that we can also go back and charge the battery. So we can provide electrical services to everything on the bus, and we can go back through here to the battery contactor, master contactor, and charge the battery. Now, the reason that will work is because this is a 24-volt battery, and this is a 28-volt alternator. So all things in the world work like this. If you're sitting in your room and you try have the AC on, like now we pressurize this room a little bit, right? So it pressurizes it. So the pressure is higher in here than it is outside. So if I open the door, then this high pressure wants to go outside to the street. And so we go, okay. So it only does that because the higher pressure in here than outside. Once it equalizes, it doesn't want to do that anymore. So this alternator is 28 volts and 24 here, so we can charge the battery. There's a difference in potential to do it. Okay, so that's that. Let's move off here. Woo, look at that. So I'm going to explain this in a second. We operate our airplane, the 172N model and the S model, 28 volt direct current systems. So this is, I know you know how to say that. Those words you know how to say. You don't know what they mean, but you know how to say it. Some of you do. You also have a 28 volt 60 ampere alternator. And then you have a 24 volt, either 14 amp hour or 17 amp hour battery, because batteries have capacity, right? So they can, if you look on the side of your Duracell batteries, you're going to see it's a some 1,000 milliamp hour battery. Something's going to say there, right? Um, so this means, for example, the 17 amp hour battery means that you can provide the battery can provide 17 amps for an hour, or 1 hour for 1 amp for 17 hours, or any multiple. But then it's done. And that's a new battery. That's what it means. So the alternator is 60 amps out because it doesn't have a capacity, it doesn't store anything. It just provides all the time. As long as it's working, it'll provide 60 amp all day long until you run out of gas. And you have a main bus and an avionics bus. And we talked about what those were, just distribution points. Yeah. Okay, so let me take a break here for 1 second, just 5 minutes, and we'll get into it, and we're going to get into how this really works. Okay, so we have a couple things that I wanted to show you. There's a poll here first. So you can kind of answer those things. It helps us determine like the depth and scope of the power hours. We should have someone on differently. Sometimes we'll ask and we say, oh, I didn't think about that. That's a good thing. And I'll share the results with you here in just a second. But what I do want to show you is we have two things that might help you if you're studying for either being a pilot, private pilot, or you're studying to be a CFI. So I want to show you those things just for a second. So I'll go here and get it. It's on our website, so it's really easy to find, but because it's right in the beginning as soon as you log onto the site. Let's do it. Here we go. Okay, so this is our website, and it's called Private Pilot Smart Study Pro. And what it does is it takes every area of operation in the private pilot ACS. It takes all the knowledge areas, risk management skills, and I do audio presentations of those. It's built for when you can't see video. But I did also do video because I had this where to do it. And then what I did is I made companion PDFs for each of these 45 different areas that are in the ACS, that's complete private pilot thing. And that's really good for getting ready for your private pilot check ride, or it's actually good preparation also for CFI because a lot of that aeronautical knowledge is missing in a lot of CFIs. So it's all in there and it goes through an audio. And you can imagine I had to do it in such a way that if I couldn't really say, look at this image or look at that because I had to make it words because you're driving or you're doing something. So that's what this is. And there's a link in the presentation, also probably here in the chat. And there's also in the presentation, you click onto it and you can do a preview of it, see what it's all about, right? So that's what it is. We also have the same thing for CFI, except for the maneuvers aren't in there. It's the oral portion, and it's 12 hours long. This is about around the same, 10, 12, and the other CFI ones, so includes the FOI, all that stuff. So that's called, that's this one. Let me show you where it's at. Then we'll go back to the presentation. So we'll go here to other courses, maybe. And here's the flight instructor ACS Smart Study Pro. So that's the same idea is there. And that will get you through. I mean, imagine having that, someone talking to you about each area of operation, what you need to know about it. I mean, that's pretty valuable. I kind of know this material pretty well. I spent a lot of time evaluating it, teaching it. I was a DPE for 11 years. Whew, not rough right there. Let me just tell you. That's the job people think they want until that, I don't know. It's what I'm not bashing DPEs, but it's pretty boring. It's about the most boring thing I can think of to do now. Okay, it looks like, do we have something coming through here? Okay, that's fine. Let me see this. Okay, let's review the poll really quickly because that's fair, right? Here, let's do that. Okay. Let's see. Which 172 system would you find hardest to explain? Electrical, by far, 83%. Okay. How confident would you explain the electrical system? Somewhat confident, about 40%. Not confident, only 4% not confident. Okay, 28% you said very confident. Have you experienced an electrical abnormality in flight? Yes, 59%. That's good. Okay. I mean, that's something. Can you teach systems using flow diagrams or schematics? I would say sometimes 43%, and a lot of people know. And what would help the most systems training? Visual diagrams, all the above one. There's teaching scripts, scenario examples, check right explanations. Okay, so that's what was in there. So let me move this out of the way quickly, move that over that side. Great. Okay, so let's go back into it. So we make sure we have time here. So this is, I really don't like their diagrams. I think they're a bit cartoonish. And also they put things on the diagram, but don't explain what they are. So as an example, um, here you see the symbol. That's a symbol. That's a symbol. And they're same symbol, same, but they never explain what this is. And they, by the way, using it incorrectly here in this diagram, but okay, it's going to serve the point. So this is a symbol for ground. So in order for any circuit to work, you have to have a path from the positive side of the battery to the negative side. So in if this symbol weren't there, it means these are all connected to the same place. That's what it means. So all those places are connected to this side of the battery. All these are common connections. And that the reason they put on the chart is because if not, you have to put wires there to say, they all go back here and it'll be clutter up the chart a lot. So to you, it just means they're connected usually to the skin of the airplane if it's metal, or if it's serious, it is a wire. We're just going to go back to the to the negative side of the battery. Okay. And then they have these things, the contactors. In this case, they call this here battery. Now they say contactor. See, before they said what? They said it was not a contactor, but it was a relay or it was a solenoid. So all those words are the same. It's the same device. Okay, so let's get with it here. All right. So what I wanted to do is take 5 minutes or 6 minutes or seven and go through basic electricity, just DC. It's real simple. So and then I think we have a chance at cracking the rest of it if we do that. So so electricity and DC circuits are very much like water in a well. So you have to get the water out of the well. So you need a pump, all right? And then you have a pipe that comes to the surface. And then at some point, maybe the pipe bends and you put a flow meter on it to see how much. And then you open up the tap and you can clamp down on the tap or open up more or less current water to flow through, right? So so that's one thing. So we can consider what makes the pressure is the pump. And that's in electricity called electromotive force. It's measured in volts. So it just provides the difference of potential, the vehicle to move the current. And then the current is actually the electrons moving in a wire, which is the water. And the more of it we have, the more flow we get and the more current we get. And then we have something that's consuming or regulating at the end. That's resistance in electricity, and that's the tap. So the relationship then is we need to get some difference of potential, some kind of difference in pressure, and that's going to be caused by the pump. Okay. And then that's going to be caused then for us by the battery or alternator. And then now we have the ability then to move the electrons through the wire. And that's the current. And we put an ammeter in there and that'll show us how much is moving in that direction. Okay, so now having said that, let's move on to here. So then because of that, we have to know what a circuit is. Okay, pretty simple. Here's a battery, symbol for a battery. This is the positive, the big N, negative on this side. And it's a light bulb here. So in this case, the current's going to flow through the light bulb and come to the other side of the circuit, and it will light up. All right, so this would be the positive side of the battery, negative side, current would flow, and the light bulb will light up. But if we interrupt that, if we cut the path, then electricity cannot flow. And so the light bulb won't light up. So we need a path always from the battery, one side to the other side. And the battery, if it had its druthers, it would just like to discharge immediately. It doesn't want to stay like that. So it's the high and low of pressure kind of thing. It's high pressure inside the building, outside low. It's a rush out till it doesn't. Okay, so we can use that. We can put a switch there. So that's one kind of circuit that we could have. And we, so the issue we have is this, is that this is 24 volts. This light bulb has to be a 24-volt light bulb. Okay, great. And so it will light. But if I decide I want another light bulb here for something else, I put two of them in here now, in here. Then what's going to happen is the voltage will divide across these two. It'll be 24 across both of them, which means it'll be 12 volts across this one and 12 making 24 volts. Now they're dim now. So I got to go back to the store and get two 12-volt light bulbs. And then if I put three in there, I got to get three light bulbs that are a third of 24 and keep going. So it doesn't not very useful. And also if one light bulb burns out, all of them go, right? Because they're connected to each other. So that circuit not good for us. So we're going to use something called a parallel circuit, which is this thing. So here we have a battery, plus minus, and we have the battery, this light bulb connected directly across, and the next one like daisy chain. We have this one, and we have more. It doesn't matter. We'll have 24 volts across each one of them, and a path back to the battery. We'll have a path back to the battery. So we can use that. So we could use that, for example, to turn this light bulb on and not have that one on, and both of them on, or none of them on. So that'd be helpful. And then if we do this, we go, well, let's put a switch right there. That's your master switch. Because if that switch is open like that, there's no current ever going to flow, no matter what these switches are, how these are positioned. But once we close it, then these have the ability to turn on. So that's what we have. So this is the idea of current flow, and we're pretty much done with that. This is what that thing is, that relay, solenoid, contactor. So let's talk about what it is. I think you'll find it fascinatingly easy, all right, and interesting at the same time. So inside of your airplane, you have a master switch, and it's a pretty small switch. It's not that big. It's not terribly small, but it's small, right? And one side is a battery master, the other side is the alternator, so it's pretty small. So there's no way that switch can take all the current from the battery through it and then go to the other things, because it would just destroy the switch. And so when you start the airplane, it's about 200 amps, 200 amperes. So that's a lot of current to move through. And the wire is the switch is very, very small. Inside, the contact points are very, very small. So it's just going to explode the switch. So that's not going to work for us. So what we do is we use the master switch to control another switch that's somewhere else. So this thing right here is just a high current remote switch. That's all it is. And so when we turn the master switch on, somehow, some way, this device will actuate. And this is actually the battery right here. The battery comes here. You see the eye hook on it. So we screw it onto here. And this side goes to the main bus. And this is what's inside. So this is big, big. So we can use our master switch somehow, we'll do it in a second, to control this switch. So here's the insides. Here's our Frankenstein bolt. That's what that's connected to. And the bus is connected over here. And currently, you should see that there's a plunger in here. It's this thing. It's a metal plunger. And it's spring-loaded to be up here where it's at. So that's its normal resting position is up. And if you look, if you had a battery here and the bus there, there's no way for the current to get over to the other side. This plunger's out of the way. So somehow we can suck down the plunger and connect these 2 points. Now we can get the battery current to flow from here and out the other side. So hence, we have a coil. That's what these two lines are, coil right here. And the property of a coil is this. If you take a battery and you connect it to that coil, so we connect negative to one side, positive to the other, it will take on the properties of a magnet. It'll have a north and it'll have a south pole. It just will. That we don't need to go into, but it will take on the properties of a magnet. So if we add this north magnet and we put a south magnet up here, this plunger could be sucked down anytime the coil is energized. So the master switch just energizes this coil, which then pulls the plunger down. And these things are on the firewall, way out away from us, so we don't have to worry about getting electrocuted. Well, we get electrocuted, high current. We don't have to have that. We don't have that around the fuel. We can put those anywhere we want. So there's one for the battery, there's one for the starter, there's one for the external power, and there's one for the alternator. So you have 4 of them usually in the airplane. Sometimes it depends on the situation. You can get the idea of them. Okay, so that's what that does. Okay, now this is a simplified version of an electrical system. It looks complicated, but believe me, it's not. Let's look. So I'm going to use a tool in Zoom called the vanishing pin. And let me grab that thing here. So here's our battery. Now remember, these points are all connected together. So we're not showing the wire that comes back to the side of the battery first to make the chart less cluttered. Okay. Okay, now the current leaves the battery. Great. It can go here to the beginning of the master switch, but it can't get past there yet because the switch is open. Also, this current leaves here, up through here, up through here. I can't get past that either. So that means this is the contactor. That's that thing we just saw. And that's the plunger that's going to close the plate. Okay, so now what we do is then we turn the master switch on. Now what happens is power leaves, current leaves here, goes through here, energizes the coil, which sucks down that plate and closes that. So now we have the ability for this battery current to come through here, to get through here, to come all the way in this direction to the main bus. And also, so now we can power anything that's on the bus. And also, we can also do this. We have the ability for the current to get to here, which is the contactor, that plunger for the starter motor, and also to go to the key switch, which is there, the start switch. So that means that if I ask you a question, just looking at it now, if I said, is it possible, would it be such that you sat in your Cessna 172 and you didn't turn the master switch on, but you turned the key switch over? Could the engine start? And the answer would be no. You should know that now, because if you don't have the master switch closed, then the current stops right here, right? You have to have the master switch on in order for that to happen. And then you'll have to engage the key switch to energize that coil, to pull that plunger down to close it, so that the power will then be available to the starter motor and it will turn. And it's a spring-loaded switch. So once you release it, it goes to the off, well, it doesn't say off, but it goes off of this position for sure. So interesting. Okay, so far. And it's interesting to say that the current flow is this direction to the main bus, right? This way. So this ammeter is called a bidirectional ammeter. I mean, it shows current flow in either one direction or the other and the amount. So you see it looks like a needle. I'll show you what one looks like in a second. Well, we can look now. Let me just go off here and take a look at it. We'll get it here in just a second. Cessna 172 ammeter. So if you're looking around stuff, just go to Google. It's simpler, right? Okay, and let me give you an idea of it. Let's take a look. Okay, so this will be this is from an S model, but you get the idea. It's got a needle. It has some markings here, plus 60, minus 60. And down here you see a similar thing, right? And other places you see a similar thing. So if the current is flowing from the battery to the bus, then this needle goes negative. And this is 60 amperes, 60 amps. So it's going to go to whatever's switched on. That's what, so it's going to be basically showing you discharge from the battery. That's what it's showing you. Okay, now let's go back to the presentation so we can see the last thing. And we turn the alternator on here. Remember, it's a 28-volt system. This is 24, right? Let me get the pen again. Okay, so now the alternator output comes to its own contactor. It gets sampled by the voltage regulator, which says, keep this consistent if you can, please. And then the power then can go to the main bus and power all those units. But look, it goes this way, the other way, to the ammeter. And the reason it's doing that is 28 volts, it's going to 24 volt land, and it's going to recharge the battery. That's what's going to happen. So as long as it's 24, higher than 24, it will do that. If the battery were 28 and the alternator were 24, the battery would try to charge the alternator. So then the current path is reversed. Right. So now I'll go back to our image. So the current path is reversed. So if we look at what would happen, it would be over here or it'd be zero, but it's not going to be negative. It's going to be going the other way. So the bidirectional ammeter says now the current flow has changed. So then the question then is what would normal operations look like if we took a look at it. So let's see the behavior of this because you probably haven't thought about it much. It's a thing. It's an ammeter like this thing. I don't know what it's for. Just I know it there, right? And if it has a red light on it, turns on. I got to do something, right? Okay, so now we kind of know. So when we first turn on the master switch, and by the way, when you first turn on the master switch and it's 172, you can hear a clunk, clunk. Listen for it. That's that relay or the contactor closing, the plunger coming down and closing. That's what that is. So once that happens, then we should see this needle in discharge down here to minus or over here minus, right? And if we turn more things on, it'll go more negative, right? So that's a normal indication. And then what we do is we start the engine. Okay, so now we start. And then what happens is then we turn the alternator switch on. And now this needle goes over here because now the alternator is providing electrical services and recharging the battery. And because the starter motor consumes so much current that has to charge the battery up, the battery's nearly, halfway gone, maybe not quite, but around there. Okay, let's just say some number. So then it's going to be way over here, this needle, because really making an effort I have 60 amps to give. Why don't I just give it to you? Right? I have all to give. You look like you need it. Here you go. Right? And so then over some time, though, it doesn't need it as much. It's getting charged. So this needle should start going down. And eventually it'll get to zero or very close to zero. And that'd be its normal way that it goes. Now, if the alternator fails in flight, this needle would go negative again. Right? So it should not go negative in flight unless you turn the alternator off for some reason. And also another thing, which is very dangerous, is that if this normal, everything's operating, turn the engine on, and this needle goes up here to 60, you're very close to it, and it stays there for a long period of time. You have to be very careful because now something has happened with the voltage regulator, most likely, and it's overcharging the battery. It should stay here for it doesn't stay very long, maybe 20 seconds, 30 seconds, maybe if that, and you start seeing the trend of it come down. So if it stays up there full on, what's happening is it's going to overcharge the battery. And what that does is there's acid in the battery, and the acid will begin to boil. And then the fumes from the acid will escape and get in the cockpit, and the pressure builds up in the battery. And at some point, the battery will explode. So this is a bad situation. So if you see that, you need to turn the alternator off. Something has failed. Now, there are circuits, high voltage protections, or other things that are there, but it can happen. So that's the normal indication. Okay, so now let's go to the POH for the 172. Here, I'll grab one. 172S model. And we'll see if we can understand it a bit better. So let's see, grab it here. Current. This one, take me just a second to bring it up. And I have 6 minutes. Whoo, shit. Do I swear or two? That'll be recorded forever, right? Yeah, forever. Okay. Let's see. Cessna 172 November model. This one. POH is here. Let's get that up in the share. Okay, let's get to the electrical system, which is here, and we'll make it a little bit bigger. Now, again, the diagram, I don't like this diagram, but I don't have to like it, right? It's what we've got, right? So let's take a look and see if we can then do what we said. Vanishing pen. Here's the battery. Here's the contactor. Currently, we can't get anything past this point because the contactor is not closed. Turn the master switch on, which is up here, and that will then energize the coil here, which will cause that to close. So then we'll be able to get current to flow from here through the contactor, up here to the starter contactor, which is not closed yet, through the ammeter to the main bus. And now we're at the main bus. And if we turn the key switch at this point, here, the key switch will energize the starter contactor. When that will then allow current to flow through the regular master switch contactor through here and to the starter motor and start the engine. Now, once we turn the alternator on, which is here, the alternator will come through here through this circuit breaker, and it will come to primary bus. And notice it says to primary bus here. I don't know why they didn't continue the line, but they didn't. Now the current's going this way, back down through here to charge the battery. There you go. So all in an hour. Can you believe it? Now, how much of it did you follow? I don't know, but I hope a bit of it, and I hope that the stuff we give you for after the presentation. You can look at it. You can look at those videos that we don't have time to go through, and we could talk about that. There's also an avionics master here, this one, and so it connects these two buses together. So the primary bus can power the avionics bus. So then another question that could be answered here is that if the master switch is off, can you turn on like the landing light, or could you turn on a radio? And the answer to that's no, because everything stops right here, right? But as soon as we turn that on, then we got this powered. So as soon as we turn on the master switch, we're powering the primary bus, which has all these things on it, whatever these are. But we have to turn on the avionics bus to power this one. So therefore, even if we have the master switch turned on, if the avionics master switch is not on, we can't power anything that's on there. Now, some airplanes have an essential bus that you can listen to the radio, can do some things from that. But most, this one doesn't. This is a very simple system. You can look at this, for example. So in the 172 systems guide that I wrote, I also redid the buses. So I redid all engineering diagrams for all these. So this is an example of here, let me grab it here. Let me share it. Yeah, you can see it. So here's my diagram for this has 5 buses on it. And so, and I described the stuff and the text up here and work through all the basic electricity stuff. So this is what's in there. That's on our website, but I took some of this and put it in the presentation as a resource. Okay, so there's that. Well, that kind of brings us pretty much to the end. There's wings credit in the chat. There should be wings credit in the chat now, or coming in the chat soon. So I'll look through the chats here in just a little bit. You can see there's wings credit in there right now. So if you want that, then now would be the time to do it. We will keep it open, so if you forget or you need to be reminded later, we can do it as long as you were here for this presentation. So that's what we've got going on. That's hopefully systems in a nutshell. The ones that are hard, things that are easy, like the lighting system and all that, I don't think we really have to talk. Every airplane's unique, but this is kind of broad based to all systems. You know now, kind of the idea of what circuits are. You have an idea of how you can use a switch to control something. You have all kinds of stuff like that. What do you say? Now I can see the chats a little bit, which is kind of fun. I like reading the chats. Thank you for explaining this in an easy, understanding way. Okay, that's good. I'm good, Daniel. And hopefully now the issue with is it going to stick? So let's look at you will look at the videos later that I provided for you, and then you can kind of go through those, and that may drive you very well to something. Maybe you want to understand a little bit more detail, and you'll go on your own. But it's like the skeleton, the framework of how things work is what I'm giving you, and then from there you can branch out. Like I didn't tell you how the alternator works, but we could learn all about it if you want to. But I don't think for this purpose we don't need to, because I only have an hour, right? If I had 5 hours, well, you wouldn't want to sit through 5 hours of that, would you? And that'll be it for this week. I'm going to close out, and I'm going to open up the room at the end. But until then, I want to say thanks for attending. Really appreciate your attendance.
From CFI Boot Camp in Miami Beach, Florida, this is the Power Hour. Welcome.